This video and associated handout discusses using free public libraries and NIST26 chromatogram and libsearch functions within the NIST search software. It's part of a full course on NIST26, which includes the newly integrated deconvolution library searching for LC-MS-MS, and here is the link to the course. I have put a lot of detail in the handout, and I'll only cover the high points in my video, so be sure to take and review the handout yourself for more detailed information. The NIST library is the gold standard for MS-MS identifications. The price is very reasonable, but shop around. The prices vary dramatically, and here's a link to the distributors. However, free public libraries and user libraries are very useful. They extend the library coverage to add additional compounds that are not present in the NIST library. So you might find them useful in your work. I have put 500,000 free public MS-MS spectra that you can download at my website. You need to make sure after you unzip them and get them into the folder in this folder that you put them in the proper place. You can see the MONA, the MS style positive and negative, and they need to be in the NIST26 MS search. And there are other libraries such as the high resolution from NIST and some you can see here some of my personal libraries, but they need to be at this level to work. Here's some detailed information on these libraries. There's approximately 30,000 unique compounds in the free ones that I put on the website. A total of 500,000 MS-MS spectra, but only 150,000 structures. The NIST26 library is substantially larger and much higher quality. You can see there's 70,000 unique compounds with a total of over 3 million MS-MS spectra, and essentially all of the spectra have structures associated with them. I'll go through some of the parameters in the video, but you might want to refer back to some of the values here, and we'll go through a practice with the chromatogram to show how to use it. So the last thing I want to talk about in the handout here in the video is that you might want to create your own updated version of these free public libraries in the future. I've done them recently, but after a while they'll add more, so you might want to do it yourself. And on my website, I will show you how to do that. And here's a list of all the ones that came from NIST at this link if you want to look and see which ones are available and even where these are available on the internet. So let's move on to the video. So here's a test file that I have brought up, and I'll show you, I've already processed it, but I'll go back through and show you how I set up the initial search parameters. The first thing, if it's not shown over here, I always like to add the structure. And so structure on plot, which is good. I've added the library ID here, and of course you can shove these around if you want to, but to get those IDs, I right-click and went to Properties and picked the ones that I wanted and shown in the display before that I find useful. So the other thing you need to do is, we'll go, if you were doing this from scratch, you would go up to Analyze the Input File, and that's this checkout test mix that I have. I might have that on my website. And you need to set up the libraries. I've set up the high resolution, the low resolution NIST, and the NIST is able to search their low resolution libraries here, which you cannot do with the user without doing a different approach, doing nominal mass, which I have a video on that also on my website. But I've added the MS style negative and positive. It doesn't matter if you mix negative and positive. You can have them all open if you want to. I'll tell it only to search the positive here, and then the MONA library. So we have all those set up. You also need to set up the tolerances, 20 parts per million and 40 here for the precursor and product ions respectively. So that's good. And that's pretty much, we'll do positive ions for these. And I would just say, okay, but I've already done this to process it to speed up the video a little bit. So I'll just cancel out of that. But those are the parameters that I set up. And at the bottom, you'll see the identifications. One thing is, you can see the libraries over here, and a lot of the libraries, I told you, do not have structures. So that's somewhat of a downside when you mix these two libraries together. So you have to decide if that's worthwhile in your work. If you only had the free libraries and you're doing a demo copy, it's definitely worthwhile. But here, you'll have to decide. But what you can do, so we'll go over and pick one of these. Like here's the best hit for that. You can see it's a good match. We have the unknown on the top and then the best library hit on the bottom, and that's from the MS Dial. So the MS Dial in general do not have structures. So what do you do about that? Well, you can send it to the NIST lib search window. So I'll right click and say library search, and I'll send it over to the lib search. But when you send it over there, you have to go and make sure you have all the parameters set up correctly again. So I'm going up here the first time and saying library search options, and we will do the search. We'll do MSMS with the precursor ion because you can look up here and it will have the precursors for these. So I'll just use N spectrum. You could, if it wasn't there, you could enter it. But all of these should, if they come from the chromatogram tab, you could do no precursor. But I'll pick the same thing. This is what they used in the chromatogram window parameters. Full spectrum search, a default pre-search. I'll have MSMS the same. You got to make sure they're here correctly, 20 and 40. Again, you have to set these up separately from the chromatogram. They do not carry over. The libraries, I have them all set up here again. And again, you have to add those. If you're doing structure searches here, you would have to pick your own structure libraries and bring them down. But we'll only be doing spectrum here, so I won't bother updating those. Automation, when it comes over, we'll turn automatic search on. So that's all the parameters there. You wouldn't have to do this here with the Spectrum import options. This is only for when you import things from a vendor's software, so we won't have to do that here since it's internal. So we pretty much got them all. I've added some different uh, fields down here, such as reverse dot, PSS dot, etc., molecular weight. And you would have to go and determine what those meant. You can resort by any of those. And there's more detail in the main course. But here we'll just talk about score. That's how it comes over when it's sorted. To add these additional things, you'd right click and go to properties. And you could add anything that you wanted to these headers. But we'll just talk about the score. So you can see the score at the top. The first one, now it has a structure because this came from the low resolution NIST library and they have structures. So this is a way to find structures that you did not find in the chromatogram tab is just come over here. So I select the first one. I left clicked on it. Now I'm using the arrows on my keypad to go down. You can see here's the one we found over in the chromatogram tab. It did not have a structure, but you can search down through them and see. The other thing here you're getting a lot of the same hits over and over again here. Remember the chromatogram tab only shows the best hit, but here you get them all. But if you want to get rid of some of them, come up here to the best matching only and click on it. And now it gets rid of things that are duplicates if they have inchy keys. Inchy keys is just a way of representing a structure, and that's how they decide if they have duplicates by comparing those inchy keys. I usually keep this off initially because I want to see all of them initially, in this case, because I wanted to pick one that had my structure on it. So that's pretty much the settings there and how you use it. Of course, this is the unknown on top, a butterfly display here, and the best structure, whichever one's the spectrum of the library, which is shown here, which again, I said I stepped through with the arrow keys. So that's pretty much how you use the public libraries. I hope you might find them useful in your work. So give them a try. One last thing I wanted to add to the video was if you go up to File, we've set a lot of configuration and within the program about the things, our preferences, so it's always good to save them. So you say Save Configuration, and you could call it whatever you wanted to. I'll just call it public underscore libraries here. So then when you come back in and you're changing how you're processing something, you can always come back to these default ones and not have to enter them all in again. Or if you change something, you don't know what you changed. This is a good way to get back to your basic settings that you want to use. So I hope you find it, again, useful, all the information about using the public libraries in your work. Good day.